Okay, day 3, parallel lines, algebraic proofs. So first go ahead and label your image as so. So we have lines R and S. We're going to go ahead and assume that they are parallel, and that is actually in our proofs as well. Up here, let's go ahead and talk about some of the relationships that we have. So first, let's go with alternate interior angles. Okay, we know that they are congruent. So some examples would be 6 and 3. Those are alternate sides of our transversal, and they're on the inside of the parallel lines. 4 and 2 would also be alternate interior. Alternate exterior angles are also congruent. So 1 and 8 would be alternate exterior. 5 and 7 would be alternate exterior. Alternate sides of the transversal, exterior outside of our parallel lines. All right, corresponding angles. So these are the angles in the same position. So like 5 is in the top left, 3 is in the top left. They are congruent. Their indicators are also same side of the transversal. One's on the inside, one's on the outside. So 5 and 3, 4 and 8, 1 and 2, 6 and 7. The last congruent would be vertical angles. Okay, these are in the same bunch. They share a vertex, so 1 and 4. Those would be congruent. 5 and 6, 2 and 8, 3 and 7. Okay, now for ones that are supplementary. Let's go ahead and stick with in the same vertices, so linear pairs. They equal 180. So linear pairs would be like 1 and 5. They're in the same section. They have the same vertex. When I add 1 and 5 together, their measurements should equal 180 degrees. So 1 and 5, 1 and 6, 6 and 4, 5 and 4, and so on. And the last relationship we have would be consecutive interior. They equal 180 as well. Consecutive meaning in a row, interior meaning on the inside of the parallel lines. So 2 and 6 are consecutive interior. They are in between the parallel lines and they're consecutive in a row. When I add those two measurements up, I should get 180 degrees. Let's use this image for the next two problems. Example 1. So here's our entire given. If we remember back to last unit, our entire given needs to go on line 1. So R is parallel to S. That's line R. So we could write the word line R is parallel to line S if we wanted to, or just write it as it was given. Measurement of angle 5 equals 15x plus 5. And measurement of angle 3 equals 12 plus 14x. Reason, that's our given. So right now we're looking at, if I were to like recreate this picture, just roughly here, we're looking at angle 5, which is this angle, and that was 15x plus 5. And we're looking at angle 3, which is this angle, and that was 12 plus 14x. Well, let's think first. What is their relationship? Okay, those angles, one's on the outside, one's on the inside, and they are on the same side of the transversal. This one's in the kind of top left, this one's in the top left. So I would consider them corresponding angles. I know corresponding angles are congruent. So for step 2, I'm going to say measurement of angle 5 equals measurement of angle 3, y corresponding angle theorem. You can abbreviate angles with the symbol angle and theorem with THM. Step 3, now I want to plug those numbers in. So instead of measurement angle 5, I know that that is 15x plus 5. Instead of measurement angle 3, I know that that is 12 plus 14x. Substitution. Let's look again what we're trying to prove. We're trying to prove that x equals 7. So I want my x to be on the left side, so I need to subtract 14x on both sides. So 15 minus 14 is x. Drop down plus 5 equals 12. Subtraction, POE. Step 5. Let's move this 5 to the other side. We'll do that through subtraction as well. So x equals 12 minus 5 is 7. Subtraction, property of equality. You could have put like the little quotation marks to say these are the same step for here. You could have also made this a 4-step proof by doing step 4 and 5 in one step because they were both subtraction. If one was subtraction and one was addition, you would have to separate it. My last step now matches my proof exactly. X equals 7, x equals 7. I know I'm done. Example 2, we're looking at measurement angle 6 and measurement angle 2. So I'm going to go ahead and resketch my picture here. Okay, 6 is here, and 2 is here. Oops, there we go. Now it's on the screen. Okay, those angles are consecutive interior. First step, go ahead and write your whole given down. So R is parallel to S. Measurement angle 6 equals 15x minus 5. Measurement angle 2 equals 65 degrees. Given. So there's a couple different ways we could go with this. Here's one way, and this is probably what I would do. So I know that these are consecutive interior. So I know if I add both of these up together, I would get 180. So I'm going to say the measurement of angle 6 plus the measurement of angle 2, that equals 180 degrees. Why? Because they're consecutive interior. So consecutive interior angle theorem. Step 3, let's plug our numbers in. So instead of measurement angle 6, I'm going to have 15x minus 5. Measurement angle 2, that's plus is 65 degrees, equals 180. Substitution. For that left side's a mess, let's go ahead and combine our like terms. So 15x negative 5 plus 50, or sorry, plus 65. That is a positive 60 equals 180. That was just simplifying. We don't write addition because we didn't cross the equal sign. So simplify. Or you could write combine like terms. Step 5. Subtract 60 on both sides. 15x equals 180 minus 60 is 120. Subtraction. POE. And step 6, divide both sides by 15. So x equals 120 divided by 15 is 8. Division POE. Our last step matches what we're trying to prove, so we are done. Flip it over when you're ready. So go ahead and label your picture again. This is going to be R and this is going to be S. We have 5, 4, 1, 6, and 3, 8, 2, 7. I do want to note on this side, it happens sometimes that you don't use every line. And on this one, if we combine 4 and 5, we would have 2 lines open at the end. So if that happens, it could be okay. So don't panic if you didn't use all your lines. All right, so for this one, I'm talking about measurement angles 7 and 8. 7 is here, 8 is here. And at the end, I want you to prove that measurement angle 1 is 85 degrees. So an angle that we have over here. Okay, so let's go ahead and step 1, write your entire given down. Take a second and do that. If you want to also, you can number all your lines, 1, 2, 3, 4, and all the way down. You should be numbering your proofs. Okay, now let's look at our relationship between angle 7 and angle 8, and then we'll come back and find one later. So angle 7 and angle 8 share a vertex right here. So I can say that those two angles are either one of two things. They're either linear pairs or they're vertical angles. Well, vertical angles are opposite of each other, so 3 and 7 would be vertical pairs. So 7 and 8, they're on the same line. They're linear pairs. So I'm going to say measurement of angle 7 plus measurement of angle 8 equals 180. Why can I say that? Because they are linear pairs, so linear pair theorem. Now let's plug in the numbers. So 19x plus 16x plus 5 equals 180. Substitution. Combine like terms. 19x plus 16x, that should be 35x. Drop everything else down. So simplify or combine like terms. Let's get x alone. Subtract 5 on both sides. 35 equals 175. Subtraction, POA. Divide both sides by 35, so x equals 5. Division, POE. Okay, now we have to think a little bit. So ultimately, I'm trying to find measurement of angle 1. Well, I've got a couple steps. I don't have an expression for angle 1, but I have an expression for 7 and 8. Okay, 7's was 19x, 8's was 16x plus 5. So let's think. Do 1 and 7 have a relationship? 1 and 7 are both on the outside, but they're on the same side of the transversal, so no relationship. 1 and 8 are both on the outside, it's exterior, and on opposite sides, so alternate exterior. They're congruent. So let's go ahead and plug 5 in for x, for 8, angle 8. So we're going to say measurement of angle 8 equals 16 times 5 plus 5. Just plugging it into the expression. So again, that would be substitution. Now we're going to simplify. Measurement of angle 8 equals 16 times 5 is 80, plus 5 more would be 85 degrees. Simplify. Okay. Now I need to write how I know that angle 1 and angle 8 are the same before I can just say, yeah, angle 1 is 85 degrees also. So I'm going to say measurement of angle 1 equals measurement of angle 8. How do I know that? Because they were alternate exterior. So alternate exterior angle theorem. Step 10, okay, I would accept substitution because we are just changing one side of the equal sign. However, measurement of angle 8 is set equal to two different things. So now I can set these opposite sides equal to each other. So measurement of angle 1 equals 85 degrees. This is transitive property. However, because we're just plugging in the 85 degrees, I would also accept substitution here.